This video is for C1, combinations of resistors and resistivity. Now when combining resistors, there are two rules. When you combine resistors in series, you add the resistances together. And what we mean by that is that two resistors in series could be replaced by a single resistor that does the same job if the resistance of that single resistor is equal to the sum of the two resistances. But in parallel, the reciprocal of the combined resistance is equal to the sum of the reciprocals of the resistances. In other words, two resistors in parallel can be replaced by a single resistor that does the same job if this equation is used to calculate its resistance. To tell if two components are in series or in parallel, you need to follow the charge as it moves through them. If the charge in passing through the second component has to have passed through the first, then the two components are in series. Whereas if the charge can make a choice and pass through one component without ever having passed through the second before returning to the power supply, then that component is in parallel with the second component. As you can see here at the bottom, the route the yellow charge took goes up, the route the blue charge took goes down. And then these two routes would return to the power supply. And there's no reason for the charge that passes through resistor 1 ever passing through resistor 2. But in the top example, if charge is to pass through resistor 2, it has to have also passed through resistor 1. And that's how you tell the difference between a series and a parallel circuit. Let's have a look at a couple of quick examples. If this is a 2 ohm resistor and this is a 3 ohm resistor, then 2 ohms plus 3 ohms is equal to 5 ohms. So a 5 ohm resistor will do the same job. If we look in parallel, let's say this is our 2 ohm resistor and this is our 3 ohm resistor, then 1 divided by 2 ohms plus 1 divided by 3 ohms, well, that is equal to 3 divided by 6 plus 2 divided by 6, or 5/6. And as the resistance of the final resistor, the combined resistor, is the reciprocal of that, it means that the resistance is 6/5, also known as 1.2 ohms. And we can write that in here. The most common mistake that students make is forgetting to take the reciprocal in the last step. Now what about if we've got a combination of parallel and series resistors, like this? In this circuit we have a 3 ohm and a 6 ohm resistor in parallel with each other and in series with a 2 ohm resistor. And the way we handle this is by taking it one step at a time. Let's first of all combine these two parallel resistors into one single resistor. So we know that 1/3 plus 1/6, the reciprocal of that, will equal this resistance. 1/3 plus 1/6 is equal to 3/6. Don't forget that reciprocal. And so the reciprocal is 6/3, also known as 2. So I have replaced this parallel branch with a 2 ohm resistor. We can now use our combining resistors in series rule to add 2 and 2 together and get 4 ohms. So the single resistor that does the same job as the network of resistors shown at the top is a 4 ohm resistor. And you'll notice that when we add resistors in parallel, it reduces the overall resistance. But when we add resistors in series, it increases the overall resistance. The second part of this is about resistivity. The constant of proportionality is called the resistivity. If our metal is a wire, and so is a cylinder, the cross-sectional area is the area of a circle, πr². Or, if we're given the diameter, 1/4 pi d squared. Be very careful to check whether you are given the diameter or the radius. Also remember that 1 square meter is not 1,000 square millimeters. It's 1,000,000 square millimeters. Also, don't forget, if you have a bundle of wires, it can be treated as a bunch of resistors in parallel. And adding up the resistance of each wire to find the resistance of the bundle, use the same approach as you did when combining resistors. And don't forget that reciprocal.